Now, at this point, I know you're sitting there thinking, I sure hope Chris takes the opportunity to one more time remind us what the number is for the native VLAN. And I know I do hit you over the head with that, but just as a quick review with some other important points, we know the default native VLAN is VLAN 1. We know that's the VLAN an access port will belong to by default. And we also know that trunk ports are members of all VLANs. So how are we tying all this together? What does the native VLAN have to do with our trunk ports? And why might we want to change the native VLAN? On the previous video, we really covered what the native VLAN trunk port relationship is. We also know that ISL, which you're rarely going to see in production networks, doesn't even recognize the native VLAN, so it's going to encapsulate everything. When .1Q is our trunking protocol, as it likely is, frames destined for the native VLAN aren't tagged at all. Now we know that .1Q's overhead is really, really low, but would rather have no overhead than low overhead. So when we can use the native VLAN concept to our advantage, it does save us a little bit of overhead per frame, which in turn over time saves us a lot of overhead because those little savings add up. Now in this upcoming lab, I'm going to be using the live equipment, of course, so when I noted here, VLANs 1002 through 1005 not shown in the following lab, of course you're going to see them here. I did trim them from the study guide, and if you bought one of those, thank you very much. But let's go ahead and head over to the live equipment. Now, what I've done here, and I want to give you a quick review here, although you can see a little bit of it at the top, is on both switches 1 and 2, I have put all of the non-trunking fast Ethernet interfaces into VLAN 12. And you can see here it's 1 through 10 on this 12-port switch. The other one, I believe, has 24 ports and a couple of gigs. And there we go. I left the gigs in default in VLAN 1 just for fun. Now, of course, in the real world, we would do some serious network analysis. You can't just look at a switch and say, okay, this one has more ports in this particular VLAN, therefore it is definitely sending more traffic. We know that's not the case. In this case, though, it's a pretty good guess. So what I wanted to show you before we move into the lab and using that command is how I did that, how I put those ports into VLAN 12. Here you want to use the interface range command, and it does take a little getting used to with the spacing. I freely admit it can be a little frustrating at first, but it's interface range, then whatever ports you want to put into your range. And what I was able to do here with one line, interface range fast 0/1 through 10, space, comma, space, and then fast Ethernet 0/13 through 24, is that I was able to put them all in VLAN 12 with one line. Two lines technically, but I didn't have to go to each individual port and type in switch access VLAN 12. That's going to get old, and even if you use the up arrow to repeat commands, you know what's going to happen. You're going to miss a port sooner or later. Now the reason, of course, I didn't put 11 and 12 in there is that they're trunking, and I don't want to change their VLAN. Let me go back to the live equipment here for a moment, and just to show you, everybody trips over the syntax sooner or later. I am not immune to that. Between the spacing and when you actually have to put the name and the type of the interface, again, takes a little getting used to, but I'm telling you, it really is worth your while. And I did the same thing here on switch 1. I went ahead and repeated the switch mode access command and just did that for fun, but you can see right there I was able to change them all to access ports. They were all access ports to begin with, but then I was able to put them all in VLAN 12 again with one line instead of having to go to each individual port. So the moral of the story, of course, is I know it can be a frustrating command, but it is worth your time to be fluent in it. Now, let's just say in this situation that we want VLAN 12 to be the native VLAN. Because we run network analysis and say, gosh, 85% of my traffic, and I'm just pulling that number out of the sky, is for VLAN 12. So it makes sense for us to make that the native VLAN because we'll save more overhead. Okay, so let's go over switch 1. Doesn't matter in the order in which you do it, but I am going to use, again, actually, let's use the interface range command again. And here what I want to do is 11 and 12, because this is what you want to put on your trunk ports. You need to change the native VLAN on your trunk ports. So now I'm in my interface range command, And the command is switch port trunk. And allowed, we're going to get to that here in a few minutes, but native is what we want to look at now. And then set the native VLAN when interface is in trunking mode, all is well. And then finally the VLAN ID, and we always love that, no more options. So it's very straightforward command. There's no trickery here, no trickeration, no odd options, just changing the native VLAN to VLAN 12. So we've got that. Let's go ahead and hit enter. And I'll do a quick say, and holy cow, look at those messages. You should be ready for this. I wanted you to see this here because what happens is with trunks, of course, is that we can really only configure one end of an endpoint at a time, right? We got two endpoints we got to configure. But the second we change the native VLAN on one of the switches and not on the other one, all of a sudden you're going to see a batch of span tree messages. Spanning tree messages, ports are going to be blocked, you know, cats and dogs living together, horrible weather outside. It really is depressing the first time you see this. You go, oh man, what did I do? When this happens, and it's not the only time it's going to happen with your switches, because you've configured one end but not the other, keep calm and just go to the other switch, and you're going to keep seeing these. Now you're going to get native VLAN mismatch messages. And you can see that's via Cisco Discovery Protocol right there at the beginning of the line, CDP. And of course, that's regarding our directly connected Cisco neighbors. So all you got to do is keep calm, go to the other switch, finish your config, and then see what happens. See if things come back the way they should. And that's what I'm going to do right here with switch 2. I'm going to use my range command again and just do 11 through 12, my trunk ports. And again, it's just switch port. Yep, you're going to get those. Trunk native VLAN 12. We'll go back and examine those messages in detail in a moment. I want to give you a real world tip about those as well. So we have fixed the native VLAN, or have we? We don't see any more messages yet. Well, we have a bunch of messages, but these are good. We always like to see the word unblocking after something's been blocked. And you can see here for each one of the trunks and each one of the VLANs, VLAN 1 and VLAN 12, that it's unblocking the interface, port consistency has been restored, and that is a very good thing. And we show the interface trunk, and here we are. And we're really where we were before, except the native VLAN has been successfully changed to 12. You always want to run show interface trunk. First off, make sure your trunks came back up the way they should and that your native VLAN has successfully changed. We certainly should be fine on the other. I thought we might get a couple of logged messages there, but we didn't. But we've got native VLAN 12. Now everything's just fine, just back the way it was. And let's examine those messages a little more in detail. Because, like I said, it can kind of take your breath away when you see half your screen suddenly fill up with messages. So if you have a little baby anxiety attack the first time you see that, you're not alone. But we've got, again, just blocking messages here. You'll notice that these are marked with span tree. Of course, that's spanning tree. Plenty of spanning tree protocol information coming up in the next part of the course. But then we started getting messages via Cisco Discovery Protocol about the native VLAN mismatch. And the thing is, with so many messages, whether it's a situation like this, or whether you're debugging, that even if it's a debug or output that you haven't seen before, the information is right in front of you that you need. You just, again, have to remain calm. And I know I keep coming back to that, but I've seen admins, kind of panic when they start seeing those messages scrolling up. And you can see here, it just tells us, native VLAN mismatch discovered on fast Ethernet 011, and notice it even tells you what the native VLAN is that was found on the other end of this link. It's saying 12, and hey, I don't understand because it's supposed to be, it's 1 over on this side. So really, that's it. That's all you got to do. There's no resetting or anything necessary after you get those messages. Once you fix the native VLAN or make it match on the other side, those messages are going to go away, and you're perfectly fine. So that is really it for changing the native VLAN, and also some good information there about the interface range command. Now, I want to show you something quickly here about fine-tuning your NCAP types. Actually, we're hitting toward the time limit. So for a single video here. So let me go ahead and stop it here, and when we come right back, we're going to take a look at fine-tuning your end cap types and talk about that N hyphen we saw on one of the switches. We'll be right back on the next vid.